I welcome you to Science Lesson 6 about calculations on moments. In our previous lesson, we looked at the definition of a moment, and we defined a moment as a turning force, and this turning force is about a pivot or the fulcrum. Pivot is a turning point of a machine, and our lesson is still about simple machines. Now, in this lesson, we are looking at calculations with some examples. Let us look at the first example. We have the first question. It reads, a man who weighs 90 kilograms sits 3 meters away from the fulcrum. Where will a boy whose weight is 30 kilograms sit in order to balance with the man? To do that calculation, we shall be following the principle of moments. And the principle of moments states that the sum of clockwise moment is equal to the sum of anti-clockwise moment. This therefore means the product of the load force and the load arm should be equal to the product of the effort force and the effort arm from the fulcrum. Therefore, as we follow that principle, we don't need to identify the load in this question. This man is having a weight of 90 kilograms, and this man is therefore the load is 90 kilograms, and the load arm for this case for the man is 3 meters. Then where will the boy whose weight is 30 kilograms sit in order to balance with the man? Therefore, this boy is used as the effort in order to balance that man, meaning the effort is 30 kilograms. Then the effort arm is not known. Therefore, let us say the effort arm should be P. And we are going to find the effort arm. Here we are going to use the principle of moments, stating load times load arm is equal to effort times effort arm. Our load is 90 kilograms. This 90 kilograms is multiplied by the load arm, which is 3 meters. This will be equal to the effort, which is 30 kilograms, times the effort arm, which is not known and being represented by letter P. Then here you need to multiply 90 by 3. When you multiply 90 by 3, this one gives you 270 kilograms. Not kilograms. It gives you 270. This should equal to 30 by P. It gives you 30 P. As we are finding the value of P being the effort arm, you now need to divide both sides by 30 in order to get the value of P. Therefore, this side should be divided by 30, then this one is also divided by 30. 30 divided by 30 gives you 1. 1 by P gives you P. This one gives you P. So the equal to have this 0 with this, leaving you with 27 to be divided by 3. 3 by 3 gives you 1. 27 by 3 gives you 9. Therefore, our p value is 9. That means this boy will sit 9 meters away from the pivot or from the fulcrum in order to balance this man of 90 kilograms. That is our first example. We have second example. We have our second example that reads, the lever in the diagram below is balancing. Find the value of K. The lever in the diagram below is balancing. Find the value of K. We have this lever drawn with the weights attached. On this side we have 15 kilograms force with each arm 4 meters. This is the distance from this 15 kilograms force to the pivot, that is the turning point. Then we have, on the other hand, the 2 weights attached. We have 5 kilograms force with each arm from where the 5 kilograms force is to the pivot. The arm there is 2 meters. Then we have another weight which is 10 kilograms force. From the 10 kilograms force up to the pivot, the turning point, the arm there is this K meters plus the 2 meters. Meaning the arm for this 10 kilograms force starts from here up to the pivot, the turning point. This one is for the 10 kilograms force. So it has been divided into 2. The other one is 2 meters and the other one is in K meters, which we are going to find out. Therefore, in order to find the value of K, we are also going to use the principle of moments, where we shall say the load times the load arm is equal to effort times effort arm. For this case, let us take the 15 kilograms force as the load. Then, if the 15 kilograms force is the load, we shall say our load is 15 kilograms force. Then you multiply it by each arm, that is the distance from the load to the pivot, which is 4 meters. So the equal to, we have the turning force on the other side of the lever, where the 2 weights, the first one, we are taking that one as the effort. The first one is 5 kilograms. Then you will say 5 kilograms force times each arm. The effort arm for the 5 kilograms force is 2 meters. 2 meters. Then this one is multiplied by this 10, the other effort, which is 10 kilograms force. Then each arm is from the 10 kilograms force to the pivot, where it has been divided into 2. So we shall add in order to get the arm for the 10 kilograms force. That is by saying 2 meters plus K. That is the effort arm for the 10 kilograms force. Then we can do our calculation here, where we multiply 15 by 4. 4 by 5 is 20. Write 0, carry 2. 4 by 1, which is 4 plus 2, is 6. that gives you 60 is equal to, this 5 by 2 gives you 10, then this 10 will be multiplied by, it is 5 by 2, that gives you 10, then this 10 is added to, this 10 is added to this 10 times its arm, which is the 2 plus k. So 10 to be multiplied by those figures in the brackets. Then here you will say this 10 multiplied by 2, 10 by 2 plus, then this 10 by k, 10 by k. Therefore, you still say 60 should equal to 10 plus 10 times 2 gives you 20 plus 10 times k gives you 10k. Still you will say 60 should equal to this 10 plus 20 gives you 30. It gives you 30 plus 10k. Therefore, for you to find the value of k, you now need to collect like terms. That is by subtracting 30 on both sides in order to leave 10k alone. Therefore, you will say 60 minus 30 should equal to 30 minus 30 plus 10k. 60 minus 30 gives you 30, should equal to 30 minus 30 gives you 0 plus 10k. And this becomes 30 is equals to 10k. Now to find the value of k, you divide both sides by 10. Where you say 10 divided by 10, then this 30 divided by 10. 10 by 10 gives you 1, leaving you with k is equals to 30 divided by 10, this 0 goes with this, leaving you with 3 and 1. So 3 divided by 1 gives you 3. And therefore, since that is the distance, it should be in meters, not in kilograms. Therefore, k value is 3 meters. K value is 3 meters. That is the value for k, which gives you the effort arm for the 10 kilograms force. There, learner, following the 2 examples, I now need you to do for me the third question that reads, the seesaw in the diagram below is balancing, find the value of y. You can do that and we shall mark our shelf in the next lesson. I thank you for watching.